Okay, so when we talk about determinants and Kramer's rule, which just happens in section 4.4 out of your textbook, basically what we're trying to figure out is how can we calculate the determinant of a matrix, and why is it useful? Why do we care? Okay. First of all, we need to know what a determinant is. A determinant is kind of a number that references all the entries in our matrix. And we show that we are calculating the determinant by putting vertical brackets, you can see them right here, and put them around the matrix rather than the normal square brackets that we're used to. Now we can only do the determinant for square matrices. That means a 2 by 2, a 3 by 3, a 4 by 4, a 5 by 5, and so on. Okay. We are only going to do it for 2 by 2 and 3 by 3. 4 by 4 might be way too much. Okay. Here's an example. Here's matrix A. To show that we want to calculate the determinant, det, of A, so we read this determinant of A, we put the vertical brackets around matrix A. Okay. Let's look at a 2 by 2 matrix first. Okay. So the determinant for a 2 by 2 takes the product of the down diagonal and subtracts the product of the up diagonal. Okay. Here's an example. Here's matrix A. The determinant of A takes the product going down, A times D, and subtracts the product going up, C times B, or B times C. Remember, multiplication is commutative. Okay, so A times D minus B times C, going up versus going down. Okay, let's look at it with numbers. That's going to make a little more sense. Find the determinant of matrix B here. Matrix B is a 2 by 2. To do this, we're going to do the product of the down diagonal. We're going to do 6 times 3. That's 18. And we're going to subtract the product of the up diagonal. 8 times negative 5. Or negative 5 times 8. So we get 18 minus negative 40. And 18 minus negative 40, of course, becomes 18 plus 40, which is 58. So the determinant of this matrix is 58. 3 by 3 determinant has an extra step. Okay. First thing you're going to do is start by rewriting the first two columns to the right of the matrix. Okay, so you're going to take column 1 and column 2, and you're going to add them on the end as column 4 and column 5, essentially. And then you're going to do the sum of the products of the downs. You're going to end up doing 3 down diagonals, add them all together. And then from that, you're going to subtract the product of the 3 up diagonals, or the sum of the products of the 3 up diagonals. Here's what it looks like. Here's matrix A, 3 by 3. A, B, C, D, E, F, G, H, I. Those are its entries. The determinant of A does the 3 down diagonals, A, E, I, B, F, G, and C, D, H. A, E, I, B, F, G, C, D, H. Minus the sum of the ups. And the ups are G, E, C, H, F, A, and I, D, B. Notice none of this is possible without writing the following two, or the first two columns following the original matrix. Okay, so let's look at an example of this. This is a little bit more complicated. So we're going to find the determinant of B. We know to get started, the first thing we need to do is we need to put this 2, 0, negative 2 on the right, and this negative 1, 5, 6, that column, on the even further right. Okay, you can see that written here, kind of behind that blue and green stuff. And then we're going to go down, 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 minus up, up, up. Okay, if you look at how I'm doing the calculations here, okay, what is oops, that's not what I'm sorry. Oh, crap. Okay, here we go. So if you look at how we're doing the calculations here, you can see that 2 times 5 times 3, plus the negative 1 times 3 times 2, plus the negative 4 times 0 times 6, all is in that first set of brackets, because that's all of the down diagonals. Down, 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 up, up, up. Okay. So we ended up with 30 minus 6 minus 24, or 30 plus negative 6 plus negative 24. Okay. Kind of cool, that works out to be 0. Then in the other one, in the up diagonals, which we are going to subtract, negative 2 times 5 times negative 4, 6 times 3 times 2, and 3 times 0 times negative 1. Oh, and I really screwed the pooch here. Okay. I need to fix something. So just really quickly, this negative 3 right here, That should actually be a 0 on the end because there's a 0 hidden there. And then this 24 should also be a 0. So I'm just going to fix that real quick. As soon as that 0 goes in there, I really should have caught that. But I made a mistake. It happens. Okay. Great reason why we want to show all these steps is so we can check things like that. Don't try and do this in your head. There's way too many steps. Okay, so let's just double check. 30, negative 6, minus 0. Positive 40, positive 36. And this is just going to be a plus 0. Oops. Okay. So that's going to change some things. So I hope you didn't write this down. If you did, quick erase it. This is actually 24. And this is going to be a takeaway of 76. Okay, and 24 minus 76 is, what is it, negative 52? Okay, I hope so. Yeah, negative 52. Okay, it's a lot of steps. It's a lot of steps here, and it's a lot of opportunities, or a lot of chances for you to make a mistake. Okay, I made 2 right there, and 1 problem. Okay, I was able to catch them because I went back and looked at it, but there's still lots of opportunities to make a lot of mistakes. So please be very, very careful. Now, where were we? There's where we were. Okay. So just looking at that, that's something you want to keep in mind. Okay. Be careful with your zeros. Why do we care about the determinant? There's something called Cramer's rule. Okay. I'm going to show you Cramer's rule for a 2x2, but you can do it for anything. Okay. Cramer's rule is a process for solving systems. We have all sorts of processes. We have graphing, we have substitution, we have elimination. We're going to add in Cramer's rule. We're going to look at some matrix inverses. We have a lot of choices. Okay. All sorts of options that are available to you. And you're going to practice Cramer's rule a little bit, but you also, like I said, you have choices. So if you like substitution, if you like elimination, then by all means, use substitution, use elimination. Okay? So Cramer's rule is a process. In order to make this process happen, the first thing we need to do is come up with a coefficient matrix. Okay? We have 2 equations here. We have a1x plus b1y equals c1. Maybe that's 6x plus 3y equals 2. Maybe this is negative 3x plus 6y equals 2. Whatever it is, you have some coefficients. Remember, coefficient is a number that is multiplying in front of a variable. Okay? So, looking at this, our coefficient matrix is a1, b1, a2, b2. Coefficient on the first x, coefficient on the first y. Coefficient on the second x, coefficient on the second y. And when we calculate the determinant of this matrix, it gets a d. This is an important determinant, so much so that we're going to call it d. D for determinant, D for darn special. Okay? So looking at this, A1, B1, A2, B2. R2, D2. No, just D. Okay? So here's what we do with it. We can solve for x and we can solve for y. And how we do it is we replace the coefficients of the variable we are solving for with the solutions of the equations. If you go back, these c's represented the constants that x and y kind of were equal to. So looking at this, when we're solving for x in the numerator, we replace the x coefficients with those c's. The bottom is the determinant of the coefficient matrix. To solve for y, we replace, I'm going to fix this one too. Okay, we replace these b's, we take what c is, and replace. Okay? So now as we look at this, we have 4 determinants to calculate, although one of them shows up twice, so I guess it's only 3. And what this fraction works out to be is the solution. Whatever this fraction is the solution for x. Whatever this fraction is the solution for y. It's actually pretty slick. Okay? If you like it, great. This is another solution you can add to your solution repertoire. Okay? Why do we care? I mean, this is great. Cramer's rule for 2x2, and actually Cramer's rule for 3x3, same process, except for now we have 3x3 matrices. Which that's going to get a little intense, so all the more reason for us to have different ways to solve 3x3. Okay. Why do we care? Well, actually we do care because if the determinant is not equal to 0, we can classify the solution as, classify the system as having one solution and being consistent. That's great. As soon as the determinant of the coefficient matrix is not equal to 0, so it's any other number besides 0, the solution is consistent. Okay? But what happens if it is 0? Well, then we got to look at some special cases. The first is when either the determinant of the x replacement or determinant of the y replacement, if one of those is 0 and the coefficient matrix determinant is 0, then we're going to have infinitely many solutions. Remember, in the case of infinitely many solutions, that means that we have lines that are coinciding. Okay? Those are dependent. Then, if we have the bottom matrix is determinant, the coefficient matrix has a determinant equal to 0, but neither of the numerator matrices do, then we have no solution. Why do we care if the determinant's equal to 0? Why do we care? Well, here's why. This d is in the denominator. And if the denominator is equal to 0, the poop hits the fan, right? Because we can't divide by 0. And so that's when we start having to talk about all these special cases. Is it infinitely many? Is it no solution? Well, we have to find the other determinants to figure it out. Okay? So we have to know what the other ones are. And then we can classify. So all of this comes from this idea of finding the matrix or the determinant of a 2 by 2 and a 3 by 3. And that's what we're going to practice. You're going to get lots of practice with that. Little practice with Kramer's rule, lots of practice with finding the determinant. Okay? Now, because I know some of you are wondering, yes, there is a way to put a determinant in your calculator. Okay, so there is a way to do that. And we'll definitely talk about that because I want you to be able to do it with your calculator, especially for those 3 by 3s or those 4 by 4s. Okay, so we're going to do a little bit of practice by hand. We're going to do a lot of practice with your calculator. I want you to be good at this. Okay, this is definitely something we need to be able to calculate, especially as we keep moving forward. Okay? So make it happen, people. Oh, crap.